Okay, friends, just so that you have some example problems, I'm going to work out some limit problems for you guys so you know exactly what the hell I'm yapping about. Okay, again, we'll be covering the ideally three methods of solving for limits when things don't quite behave the way we would like. Okay, so we'll cover things like rationalizing, multiplying by conjugate, um, and factoring. Okay. In efforts to remove the discontinuity. Well, remove. Okay. So these are going to come from our homework problems. Yeah. Actually, what I'll do first is let's take a look at problem number 7 on our homework. Okay. Which is going to be x squared minus 2x plus 1 all over x cubed minus x. Okay, so the question is it continuous? Why or why not? But I'm also going to take the limit of it as well. Okay, so note continuity implies the limit as x approaches a from both sides of f of x is equal to f of a. Okay, a lot of you guys just check for this, which, like, fair enough. I was fully hoping you guys to do this part too. Okay. We want this at x equals 1. So the first thing you're going to do is plug it in. So you're going to go 1 minus, I guess you want to be very specific, 1 minus 1 squared minus 2 times 1 plus 1 all over 1 cubed minus 1, which is going to equal 1 minus 2 plus 1 all over 1 minus 1, which is going to equal 0 over 0, which is bad. So we know it's not continuous, but we'll see if the limit exists as well. Okay? So take the limit as x approaches 1 of x squared minus 2x plus 1 all over x cubed minus x. All right. First thing I'm going to do is I'm going to factor. So this will be our factoring method. So limit x approaches 1. Please don't drop that sign. This is going to give you x minus 1 squared all over x minus 1. And that's going to equal the limit as x approaches 1 of x minus 1 over x, because there's one of these up here and one down here. And let's see if we can plug it in. Yes, we can. Plug that in. That gives you 1 minus 1 over 1, which is 0 over 1, which is 0. So the limit as x approaches 1 of x squared minus 2x plus 1 all over x cubed minus x is equal to 0. F of 1 is undefined. F of x is not continuous, but the limit does exist. Okay. Let's take a look at number 2, which is going to be f of x is equal to the root x plus 6 all over x plus 2 at, actually this one is less interesting. I'm just going to cut this out. Tee. Let's look at let's get number 8. Okay, which is going to be square root of 2x plus 1 minus 1 all over 3x at x equals 0. Okay. Oh no, actually, yeah, this is problematic. So if we try to plug it in, f of 0 is going to equal 1 minus 1 over 0. So function is not continuous because you're getting 0 over 0, right? But you can still check for the limit, okay? So the limit as x approaches 0 of root x, sorry, 2x plus 1 minus 1 all over 3x, right? We're going to multiply by the conjugate, so we're going to multiply by root of this on top, root of that on the bottom. 2x plus 1 on top plus 1 all over 2x plus 1 on the bottom plus 1, like that, right? And that should give us the limit as x approaches 0 of 2x plus 1 minus 1 all over 3x, 2x plus 1 plus 1, like that, right? And that we can simplify down to the limit as x approaches 0 of 2x all over 3x, 2x plus 1 plus 1, like that. So look, we can simplify that down. And that gives the limit as x approaches 0 of 2 over 3 parentheses 2x plus 1 plus 1, right? And try to do that again. Plug it in. That gives you 2 over 3 times root 1 plus 1. Notice how I dropped the limit sign because I've already applied the limit. That's going to give us 2 over 3 times 2, which is going to equal 1/3. Okay. Let's do number 10. Let's simplify these bad fractions, right? F of x is equal to 1/4 plus 1 over x minus 4 all over x at x is equal to 0. Continuous, probably not, but let's find out. F of 0 is going to be 1/4 plus 1 over -4, which is going to be -1/4 plus -1/4 over 0, 0 or 0. So, not defined, but let's see if we can take a limit. Limit as x approaches 0 of 1/4 plus 1 over x minus 4 over x. Let's do some keep, change, flip magic. X approaches 0 of keep, change, flip, which is going to give you the limit as x approaches 0 of 1 over 4x plus 1 over x, x minus 4. Okay. They don't have the same common denominator, and that's okay. This one is missing an x minus 4, and this one is missing a 4. So that's going to equal the limit as x approaches 0 of, again, this is missing an x minus 4, so we multiply that over, x minus 4 all over 4x, x minus 4. This one is missing a 4, so we multiply that over, 4x, x minus 4, just like that, right? Limit as x approaches 0. Let's combine some terms, x minus 4 plus 4 all over 4x, x minus 4. And that's going to give the limit as x approaches 0 of x all over 4, x minus 4, just like that, right? And that's going to equal the limit as x approaches 0 of, oh, sorry, I forgot a 4 or an x there. These two cancel out, so that's going to give you 1 over 4 x minus 4. You apply the limit in, and that's going to give you 1 over 4 times -4, which is 1 over -16. Okay, cool.